This is a kind of hard question. We should expect it to be hard. We're in the last grid in, so typically that's where the difficulty has picked up again, and it should be hard. However, I think a lot of people give up on this one too early. Basically, what we should do is just follow instructions. And I know that the question is short, but there's a very clear instruction. If it's telling me that a is equal to this thing, 5 radical 2, then we should substitute, right? And plug that point into the equation. That's what we always do in algebra. When we have like a value of a variable, we substitute it. So let's just do that. So 2 times 5 radical 2 is equal to radical 2x. Now I know we're not super confident with radicals, but let's kind of just, again, one step at a time here. The main place where people are going to mess up, I think, is right here. We have to multiply this 2 by the 5 root 2, and people kind of forget how that works. The short answer is just the 2 does not get distributed to both. It only goes to the 5 because there is no reason to distribute. Radical 2 is a messy number, but let's pretend for a second it's 5 times, I don't know, let's just do 3. So if that's what we had, we're not going to distribute the 2 because 5 times 3 is 15. Like, we can do that. And so when we have multiplication, we don't distribute. Everything does kind of just automatically mix together. And so we only really do distribution if it was something like 2 times 5 plus 3. Then we could distribute, but honestly, with this case, we would just add the 5 and the 3 together. But hopefully that wasn't confusing. Point is, with radicals, the number in the front is what's going to get multiplied when we multiply them. So now we have 10 root 2. The other thing that's kind of helpful to know is that, again, this is like a multiplication problem. So we can break things up, and we can say that this thing on the right is the same as radical 2 times radical x, right? Because it's almost like the radical kind of is applying to both, and we can apply to them both at the same time, or we can kind of separate them. And if we do that, then I think it's pretty clear. Oh, okay, wait a minute here. I've got a radical 2 and a radical 2, and they're both being multiplied. So those can just kind of cancel out, leaving me with 10 is equal to radical x. Well, now I've got a problem I can handle, right? Just square both sides, and 100 is equal to x, and that's my answer. Radicals and the rules about radicals do not come up very often on the SAT. You're likely to see 1 or 2 questions per test, and sometimes you can just kind of get by with the calculator. But here's a case where, yeah, they're pretty just explicitly testing the rules of radicals. So hopefully this serves as a nice little refresher. It's probably not going to get that much more complicated than this. But it's the kind of thing that you could easily practice on Khan Academy. It's just a basic algebra thing where there are certain rules, and eventually with enough repetition, they just kind of get absorbed, and you just do them without even thinking. That's how you want algebra to feel. But yeah, you could probably have taken a good guess on this one anyway, and that's okay.